Here we go.
Neutron, proton, mass effect, lyrical oxidation. You're irrelevant, mass spectrograph. Your electron volt, atomic energy erupting as I get all open on betatrons, gamma rays, thermal cracking, cyclotron, any and every mic you're on. Transuranium, if y'all was uranium, molecule spontaneous combustion. Pow!
Hello, Year 11. I'm afraid I will not be with you for the next couple of weeks because my knee has taken longer to heal than I had anticipated, but that doesn't really matter because you're going to spend these next 2 weeks writing your conclusion and evaluation to your controlled condition coursework assessment. So we're going to get this done in the next 2 weeks, and after that you're going to have the rest of this term to perfect P7 and get ourselves sorted for the final exams at the end of the year. What I wanted to do really briefly was just go over a couple of things from the student mark scheme that I've issued you with before. So you guys have seen this before. It's the exact same one that you used for your physics and for your biology that you did with Michelenberg, and just a couple of points I'd like to go through quickly from here that will be relevant to you. Yeah, just some feedback because I've marked your physics ones. I'll give you the marks for those in due course, but basically a few points from this that I want to just go through. Basically, guys, this column, you need to have a careful look at all the things in this 5 to 6 mark column. You cannot get 7 or 8 marks for this section here, and if we're going for A's and A stars, we want to be getting the 7 and 8 stuff, but you can't get the marks for this unless you do the stuff in these boxes as well. So please look very carefully at this column. So the first few sections, basically SA and SB, this is all the stuff that you should be doing in your introduction section straight off. So you want to identify all the main variables. What possible things affect the energy? You need to identify all of them. You need to come up with a hypothesis that is based on science and explain the science behind your hypothesis, and then you need to come up with one factor that you want to test, and you want to do a quantitative factor as well, a quantitative hypothesis, please. Next up, this is very important, something that not everybody did, was when you discuss, you needed to explain what equipment and method or techniques you're going to use, and you need to explain the range. You need to explain the range of measurements that you have decided to take. You need to justify your choices. Okay? So you have to explain, why did I decide to do this volume? Why did I decide to do this concentration? Why did I decide to spread them out like that? Why did I decide to do this many repeats? You've got to justify it, you've got to explain it. Then, this is coming onto the second page, this stuff here, which is all to do with here, this is the evaluation, this section, and this bit here, these two down the bottom are the conclusion. So just a couple of points from these that I wanted to quickly run through. Basically, you guys did the evaluation stuff pretty well, like in what you were producing was pretty good. Discuss some problems, suggest some improvements, say what you could do better, talk about how reliable your data is, talk about your range bars, talk about your line of best fit. Is it a nice straight line? Are you happy with it? Bloody blah. That was all good. Stuff to do with the conclusion. Talking about secondary data. Look, this is something that annoyed me a bit. It was a couple of people did not include your secondary data. You have to give me a copy of your secondary data. So when you use it, I want your secondary data included. Please. So put a copy of it in there, and you need to reference it. So you need to say, where did it come from? And what you need to do as well is discuss the level of confidence that can be placed on your secondary data. So I collected this data from another student, and I think I can trust it. Well, you've got to explain how much can you trust it. You've got to discuss whether it supports what you've got or contradicts it or whatever. You've got to do some discussion of it, you've got to include it, and then you've got to say how much you can trust it, and you've got to do some decent analysis. And finally, this thing please, please, please make sure you're doing this. You need to explain your hypothesis. Has your hypothesis been met? Was your prediction correct? And then you need to say whether the trends support it. So the straight line or the curve or whatever, it does support it. And you need to explain, does your science from the introduction support your hypothesis? You need to rediscuss this science. You need to talk about that science again and say whether or not you're happy with your hypothesis, with the science, with what's happened, and whether you got what you expected. Then this thing as well, what data could be collected in order to increase confidence in your hypothesis? You've had a hypothesis, you've done a test, you might think it's been supported, but what would make you even more sure? What else could you do to get extra information, extra details, make yourself extra happy? That's what you've got to now be thinking about. Okay, so we've got 2 weeks to get our conclusion and evaluation done. Please email me copies of your work if you want stuff looked at, and I will get back to you. Those of you who did so over the Easter holidays have seen that I've done that nice and quickly, so please just get back in touch and send that stuff over to me, and I'll see you in a couple of weeks.